I'm Thomas Borchert, reporting for AVweb and fliegermagazin, of which I'm the editor. We're here at Aero Friedrichshafen, and we for the first time have an engine area here where we are showcasing the latest developments in engines, anything from really big avgas engines down to small, tiny electric engines, and there's 3 of them that we're going to show you in some more detail. The first engine we're looking at is a study done by Gird Hirth Motoren, a German company that does engines for ultralights, LSAs, and very light aircraft, powered parachutes, stuff like that. And the goal here was to have a very light engine that still burns kerosene. And the way they solved this is by igniting the kerosene. And here's Gird Memmesheimer, development engineer with Gird Hirth. So this is basically a dieselized 2-stroke engine running both on kerosene and on gasoline. We have developed a special ignition system that makes diesel run with an ignition plug, which makes the engine very much lighter than conventional diesel engines. Conventional diesel engines need extremely high compression to ignite by themselves. We don't do that here. We inject fuel and air under pressure and then ignite it with a conventional plug system. Up there we have an injector for the fuel and for the air, and what we do is we pressurize the air in this compressor here to 7 bars and then put it up in the common rail up there where the fuel gets injected also, and the diesel is injected at 6 bar. And the compression ratio in the cylinder is 7:1. So we inject the mixture that we prepared up there and then ignite it with a conventional plug. The concept of this engine makes sense because A, kerosene has much better availability worldwide, and B, it is safer in use. For example, when you think of UAVs on board of Navy ships, where you don't really want to have gasoline around. So that's basically what we do here. The Hirth engine may seem light already to some, but this electric engine of Electravia, a French company, is really small and really light. Here's Lavrand from Electravia.
In fact, at the beginning I had a small aircraft, and I had a lot of problem with my 2-stroke engine, and I decided to put an electric engine on it, and it was a success. So we start Electravia, the company, and we put electric engine on every type of aircraft we can do it. And it's a motoglider, of course, it's ultralight, it's delta trike, it's power motors, every aircraft adapted to electric engine. Power, small power, of course, up to 50 horsepower, about 50 horsepower. We can do better, but after it's a problem of batteries. You have to take a lot of batteries, and it's not very interesting. So for small power, it's very interesting to have electric engine, of course.
On to bigger stuff. Price Induction is another French company, and they are developing a small jet engine, the first turbofan, they say, that was exclusively developed for general aviation use. Here's Mathieu Etcheparre from Price Induction.
So the Gen 380 is a turbofan engine dedicated to the general aviation market. We are targeted towards aircraft of about 2 tons that have 4 to 6 seats, and that would fly in between 10,000 and 25,000 feet. The typical cruise speed would be located between 200 and 250 knots. So in terms of architecture, the Gen 380 is a very simple engine. It's based on a tried and trusted architecture, which is a 2-spool unmixed flow turbofan. But within this architecture, we've added some innovative concepts. We have an electrical starter generator on the high spool speed, which this prevents us from having a mechanical gearbox for accessories. Our fuel and kerosene is pumped through electrical pumps, which are powered by our starter generator once the engine has started. Once again, this simplifies the overall design of the engine because we don't have an accessory gearbox. This allows us to have a much simpler maintenance scheme. In terms of thrust, the engine can develop around 250 kilograms of thrust, so about 560 pounds of thrust. It has an SFC of 0.78. So this would be, in typical cruise conditions, you would reach about 100 liters of kerosene per hour. So that would be at 15,000 feet and cruising at 230 knots. The overall weight of the engine would be 85 kilograms, so about 175 pounds.
Also at the engine area you find a cutaway of the Austro engine AE300 and 19 other exhibits. Of the Austro engine you'll find a detailed review elsewhere on AVweb, and if you want to see more about Fliegermagazin, only in German I'm afraid, at www.fliegermagazin.de.